Good morning, or good noon time, I guess. My name is Jim Meehan. I head up product marketing at Kentik, and we're going to talk a little bit about managing hybrid and multi-cloud networks with Kentik. So we'll talk a little bit about the solution and container networking as well. And then we'll go through how this applies to the M&A working group requirements, and then we've got a little demo at the end. So I apologize, the slide changed aspect ratios here on the 4:3. The Kentik platform is a software as a service platform that collects a variety of data sources from infrastructure broadly across on-prem, so routers and switches, but also cloud environments. So from traditional network infrastructure, we collect things like NetFlow, SFlow, IPFix, raw packet data, other network metadata, so we can map all that network activity to things that are meaningful to the business. Usernames, application names, location names, pod and service names in container networking environments. From cloud infrastructure, we collect VPC Flow Logs from AWS and GCP and NSG Flow Logs from Azure. So this gives us broad visibility across wherever your applications run. And our goal is really to help enterprises understand the network behavior of their applications and how applications impact the underlying infrastructure and vice versa. From an application assurance perspective, we're talking about things like inventorying which applications are present on the network. So we don't always know, especially if there are multiple teams involved in deploying applications, exactly what's there, especially in cloud environments where many teams may be running fast. Understanding dependencies between applications, both internal and external dependencies. So a lot of organizations don't know that they have applications that are dependent on Twilio or Google Maps or other things outside. And additionally, for migrating applications from on-premise infrastructure to the cloud, you don't necessarily know what dependencies, internal dependencies those apps have that might be impacted if an app or a component moves to the cloud. We can also profile and detect deviations from historical normal activity. So if we see applications talking to things they haven't talked to before or above or below baseline, we can apply some machine learning techniques to automatically pull out deviations from historical behavior. From an infrastructure assurance perspective, we can detect when infrastructure components may be experiencing issues. So do I see any VMs, containers, servers, routers, switches that have stopped sending data, are sending more or less data? Are there new devices on the network? So we see activity to or from IP addresses, MAC addresses, VMs in cloud environments that haven't been there before. So we can take a snapshot of the top end, tell you if something that was always in the top end is no longer there, something that was never in the top end before suddenly appears. And then from a network assurance perspective, we're talking about things like capacity planning. If I have a cloud interconnect, which applications are causing the traffic growth on that? Is that growth business necessary, or is it due to inefficiency? Or misdeployed, misconfigured applications that are talking between on-prem and cloud. If in cloud environments, we're interested in things about understanding what's driving costs. So if I have a bunch of inter-region traffic or internet egress traffic that I'm getting a big bill for, which services, teams, applications are generating that? And all of the same kind of understanding what's present on the network. And then performance as well. So out of GCP and on-premise infrastructure, we can get latency, packet loss data, understand which components in an app are responsible for that, or which components in the network are responsible for that. In other environments, we don't get that natively out of the flow data, but we can deploy agents that produce that data from packet capture on endpoints. So let me switch over to the demo environment here. So the Kentik platform, as I mentioned, is primarily a software as a service platform. So we collect data from infrastructure over private interconnects, or you can send it over the internet. We make it easy to add in all of the different data sources, both the raw network data, but then a lot of additional metadata that we can overlay on that to make it meaningful for people who are not intimately familiar with what each IP address does on the network. So some of that enrichment is built in, things like geolocation, routing data, but then you can also add in your own enrichments, application names, locations, users, whatever metadata makes this meaningful for your organization. We have a lot of out-of-the-box dashboards that make it easy to see what's happening. So each of these panels is giving me a view, in this case, about what's happening in cloud environments, what's the traffic volume for each of my GCP, Azure, AWS ingress, internal traffic, egress. So each of these lines represents a different environment. We can also build maps that, or Sankey diagrams that visualize things like region-to-region traffic flows. So how much traffic do I have flowing between regions? I could drill down into this and find out specific VMs, IP addresses that are responsible for that. We also have dashboards that give us views into specific individual environments. So now I'm looking at GCP individually, similar maps, but a little bit more detailed information about services, applications, top talkers, latency matrices. So VM by VM, what's the latency observed between each? What's the latency observed zone to zone? So these are all color-coded. You can also apply brackets, so you could get red, yellow, green color codes depending on different latency thresholds. Maps that make it easy to understand those metrics on a per device or per application basis. Each of these panels I can drill down on. So everything that you see in a dashboard is built from the Kentik Data Explorer, and this allows me to pick both the elements that are included in the output as well as the filters. So if I want to filter on a specific application, IP address, if I want to add additional elements into this diagram, I could put in things like destination IP. Now I get wonderful. All right, well, I'll continue on to the next one since it's already loaded. We can also map container orchestration metadata onto network traffic. So one of the difficulties about moving to containerized workloads is that from a network activity perspective, IP addresses are pretty meaningless. So we can pull metadata out of Kubernetes API. We actually have a container that can deploy in your cluster and provide us a real-time mapping of pod names and cluster information to IP addresses, so that when we see activity between pods, we have that mapped right in the Kentik UI. And those are also dimensions that you could set filters and alerts on. We also have matrix view here. So here's an example of the color coding or bracketing that I was talking about. So if pod-to-pod latency is less than 300 milliseconds, it's green. If it's between 300 and 7 milliseconds, it's yellow. If it's over 700 milliseconds, it's red. Let's see if this is... I meant to pull up the alerting, but... guess we'll have to end there. A few minutes for questions. It does support EKS, yes. Sorry, what kind of monitoring? So network activity, we don't go into the application layer unless you have the packet-based agent deployed. So there's some trade-offs, right? If you want application layer data, there's the monitoring footprint is a little bit heavier. For just this basic layer 3, layer 4 data, we can get that right out of the infrastructure with no, it's an agentless type of solution. Yes. Yeah, I don't know what's going on with the Wi-Fi here. I should have brought the dongle for the wired network, I suppose. All right. I meant to go into the alerting section, but there is a whole alerting detection that pulls out the correlations between what is causing latency within an app stack or a network stack. Statistical analysis, we're working on some cluster analysis, which is a near-term roadmap. All right, I think time is up. Thank you for taking a moment.